as the transfer of energy. Huh? Are you okay here?
Yes, sir.
Now, what you have been doing here is what is temperature. Now we're going to look at the heat, eh? Temperature and heat, are they the same? They're not the same. Temperature is what? It's a fundamental quantity, right?
Yes,
that is one difference between them. What about the heat here? Heat is a derived quantity.
Yeah.
Are we okay? And also what? Heat is what? Is an energy. Heat is an energy, right? And whilst temperature is what? Is a state of matter, right? Because we talked there about what? About molecules. The faster the molecules move, what happens? The higher the temperature, right?
Yes, sir.
The lower the molecules move, what happens here? The lower the temperature. What if the molecules are not moving at all?
Temperature remain constant.
Yeah, exactly. That's what I'm saying. What temperature is what is defined as what? As the measure of the average kinetic energy
of the body.
Right?
Yeah, sure.
Because when you run, what happens now? When you run, the molecules in the system move, right? And what happens now? When you're in motion, the energy which the body possesses now is called what? It's called a kinetic energy. So all what we have been doing here is under temperature, right? Now we're going to look at energy now. Sorry, heat. Heat is a form of energy, right? Which transfer what? Heat is what? Is a transfer of energy, right?
Yes, sir.
From one body to another body. Due to what? Temperature difference. Heat is what? Is also a transfer of energy from what? From a cooler body to what? From a hotter body to a cooler body as well. Okay? Now let's assume here we have what? We have a package here, and here we have what? Let's say we have 60 degrees Celsius here. Okay? And we have another body here that has what? 20 degrees Celsius, which has a higher temperature here. This one, right? Now we are going to transfer here from this point here to this point here again. This man is not transferring what? Energy to this man. Okay? And when it transfer energy here, what will happen now? Let's say here we have 40 degrees Celsius now, and this man is also what? 40 degrees Celsius now. What happens now? The temperature are the same, right?
Yes,
now see what? In this case here, this man has what? Has transferred energy to this man. So say what? Heat is what? Is the transfer of energy here from one body to another body due to what? Temperature difference.
That's the heat.
Are you okay here? That's the heat. It's a form of energy, right?
Yeah, it's a form of energy.
Are you okay here? Yeah. So in that next here, you are going to look at the notes now. You are going to read the notes, okay? What we are concerned about here now is what is the calculation. Since you have the book now, go through the book here, but we are going to look at the calculation in that particular book. I want in the area here that we calculate on the heat here is what is the heat capacity. And also a specific heat capacity, right? Heat capacity here is what? Is an energy required, is that heat that is required to what? To raise the temperature of what?
1 kilo
of a body, of anybody, right?
Yeah.
Anybody of a given mass of a substance to what? 1 Kelvin.
Sure.
Now look at the word here. Any. The word any. This word, heat capacity, right? Is the energy which is required to raise the temperature of what? Of a given mass. Alright? To what? To 1. To any mass, right? Any what? Any given mass to what? To 1 Kelvin. 1 K. Heat capacity and specific heat capacity, they are not the same. Are you okay here? Are you the same here? They are not the same. They are not the same, sir.
What is the difference?
We have to look at the differences, right? You have latency of vaporization, right?
Yes.
Latency of fusion, right?
Fusion, yeah.
So, and here we are looking at what? Heat capacity. Now, what is required? When you talk about capacity, what you can accumulate, right? That's the capacity. Now that like here, if you have heat capacity here, heat capacity is now equal to what? Now we talk about what? The amount of heat required, right? The amount of heat required, the quantity of heat that is required to raise the temperature of what? Of any given mass of what? Of a substance, right?
Yeah,
to what? To 1 Kelvin. You are using the word any. when you go to specific heat capacity, you have what? As look at what specific, it means what? Permanent, right? Actual. Are we okay here?
Yes, sir.
So the heat capacity here is equal to what? The amount of what? Of energy required. Are we okay here? Now, this one is equal to what? Quantity here. Quantity here, all upon what? All upon change in what? Temperature, right? Change in temperature. But we use temperature here in this case as what? As theta, right? Change in temperature. Are we okay here? Are you right? So therefore, if we to symbolize this one here, this one is equal to what? Here is what? Here is Q here, all upon what? All upon change in what? Change in theta, right? Here is what? Here is upon what? 1 times Q here. This one is the heat, right? The heat required. So therefore, here is Q here is now equal to what we have now, C here, and we have what? Change in what? In theta. Is that also, sir? So this is the heat, and also heat here. And then you have, since the specific heat capacity, and change in temperature is what? When you subtract the two temperatures, then you have what? You have the change in the temperature.
Q is the heat.
Yes, sir.
Okay.
The amount of heat, right?
The mass.
Mass.
Okay.
Are we okay here?
Okay, so if now do mass,
No, sir. Yeah, that's the difference between what? This one was just asking here. Heat capacity and specific heat capacity, they are not the same, sir.
Okay.
Now, look at the definition here. The amount of heat that is required to raise the temperature of any given mass. Any, look at the word. Any given mass of a substance. The key word there is what? Is any. Are you okay here? So what? So 1 Kelvin, right? Why the specific heat capacity is what? Is that temperature which is required to raise the temperature of what? 1 kilogram to what? 1 kilogram of what? Of a given mass, right? So what? So 1 Kelvin. Are we seeing the concept here? This man is what is specific, right? How many mass needed here? 1 kilogram. Is that also, sir? So raise the temperature of 1 Kelvin. The mass of 1 kilogram is required to raise the temperature of what? Of 1 Kelvin. But yeah, do you have any specific mass here? No. It is what? Any mass, right? It can be what? 2 kilogram. It can be what? 0.5 kilogram. It can be what? Any given mass. Are you okay here? Then mind you here. We talk about what the specific heat capacity here. The SI unit is what? It's joules per what? Per kilogram per Kelvin. Are you okay here? This one is what? It's just per Kelvin. No mass, right? Not kilogram per watt per Kelvin. Just per what? Per Kelvin. They are all in the book, right? If you go to the book, you can see all of these things there. Are you seeing them now? Good. Now, heat capacity here, or specific heat capacity is what? A C here is now equal to what? Now you have Q here, all upon what? All upon M here, change in what? Change in temperature. Here you are seeing the mass because you have what? 1 kilogram of mass is needed to what? To raise the temperature of what? Of 1 Kelvin. Have you seen the difference now? Yes, are you okay now, sir? Are you okay with the differences now, right? Good. This one for the specific, look at the word specific. Alright? It means actual value. Is that also, sir?
Yes, sir.
Good. So, under the specific heat capacity here, these are the formula that we are going to use, right? So therefore we say Q here is now equal to what? M, C, and then you have what? Change in what? Change in temperature, right? Or we can say what? Q here is equal to what? M what? MC theta.
Okay.
This formula is what we are going to use throughout.
For the heat capacity.
Yes, sir.
Okay.
Yes,
sir. So, like only formula is for heat capacity.
No, sir, not the formula. I will give you another formula, yeah? Now, that Q here is equal to what? IVT. I is for the current, V is for the voltage, and T is for the time, right? And also Q here is equal to what? Is equal to PT. I'm not in the book, sir. Yes, I know right here in the book. Have you seen them now?
Yes, sir.
Good. Are you okay now? This one,
for lifting.
of course, this one is what is power, right? Are you okay here? This one is for what? For time. But we have power here is equal to what? V square all upon what? All upon I again. Check the notes. On the electric method here, I give a lot of formulas, right? Is that also, sir?
Yes, sir.
Good. So therefore, these formulas, we are going to look at them now. Check problem and work and solve the problem. Let's see how they are applicable. Are we alright? Question 1.
An electric heater rated 48 watts, 12 volts, and it's placed
Yes, sir.
in a well insulated metal
Yes, sir.
of mass 1
sir.
kilogram at a temperature of 18 degrees C.
Yes, sir.
When the power is
Solution,
switched-
right?
Yes, sir.
Let's take solution. Is there any problem with that solution?
No.
Okay. This one you must be careful, eh?
Yeah.
No problem.
No problem, right? Let's go. So
When
yeah, we are giving here.
Yeah.
Yes, sir.
When the power is switched on for 5 minutes,
That's the question all over. Yes, sir.
an electric heater
Yes, sir.
rated 40 watts.
Now,
48
power,
watts,
right?
Yes.
Power.
It's
Now we have
48 watts.
power here. Power is equal to P is equal to what? 48
Watts.
watts, right?
Yes.
sir.
12 volts.
Now voltage,
V is placed in a well
voltage
insulated
V
metal.
is equal to what?
12
12 voltage, right? Yes, sir.
is placed in a well insulated metal of mass 1 kilogram at
Now we have the
a
mass here, right?
Mhm.
Mass M is equal to
1 kg
1 kilogram. Yes, sir.
at a temperature of 18 degrees C.
Now that is the initial temperature, right?
Yes, sir.
18 degrees C,
Yes, sir.
Celsius, right?
Yes, 18 degrees C.
Now we have what? Initial temperature, right?
Yes, Celsius.
Now initial
Temperature.
temperature. Now theta over there is equal to what? 18 degree Celsius.
Yeah.
Yes, sir. Let's go.
When the power is switched on for 5 minutes, that's
Now time is given to us, right?
Mhm.
Time.
The
Time
temperature.
T is equal to what? 5 minutes, right?
Yes, sir. The
Now let's go back this one now. You know that time is always measured in what, in seconds, right?
Yes.
So when you have the polar here in minutes, what do you do here?
55 times 60.
Now you have T here is now equal to what? 5 here times 60 seconds makes what? 1 minute, right?
300 seconds.
And this one is equal to what? 300 seconds. Yes, sir.
So, the temperature of the metal rises to 34 degrees Celsius.
That is the final temperature now, right?
Mhm. Find the specific heat capacity of the metal.
Final temperature here, theta 2 is equal to what?
34 degrees C.
34 degrees
C.
Celsius.
Yeah,
Now, whenever you have a double temperature here, we have change in temperature.
yeah.
And that change means we have to subtract the two temperatures, right?
Yeah.
Therefore,
Find
so
the
change in
specific
temperature
heat
here
capacity of the metal.
is now equal to what? Theta 2 minus what? Theta 1, right?
Yeah.
This one is now equal to, now where do
34
we have
minus
34
18.
here minus what?
18.
18. And what is that?
4 minus 18 is 12. 34 minus 18. 16.
16,
Yeah.
So therefore, come now, what are we have to find here?
The specific heat capacity.
Now, come here.
SHC.
We know that Q here is now equal to what? MC what? MC theta, right?
Yes, sir.
But mind you, we know what is Q now, right?
Yeah.
We also have Q is equal to what? PT.
PT, yeah. At the
Alright?
time.
Now, Q here is equal to what?
Time.
PT, right?
Yeah.
Are we okay here?
Yeah.
Now, what do we have to find here? The specific heat capacity, right?
Yes, sir.
Now, if that's the case here, power is given to us. Is that also, sir?
Yeah.
Time is also given to us, right?
Mhm.
So therefore, you can just come and what and substitute. Now, we say power here, P is the same as PT here is equal to what? MC what? Theta. Are we okay here? Power is given to us. And what is the power here? Now, we substitute the values,
I thought
right?
we have to find Q, then substitute to the value.
No, sir.
Okay.
We have 48 here. Times what? Time. Do you know the time? What's the time here? 300, right? Equal to, now mass. Do you know the mass?
The mass is 1.
Times specific heat capacity. Do you know
Okay,
that
sorry.
mass?
I thought that Q for friends.
Times, now theta, what is theta now? 16, right? This is how simple this question was, eh?
Yeah.
Now 48 times 300, what is that now?
14,400.
14,400.
14,400.
14, eh?
Yeah.
Yeah, 14,400.
00, right?
Yeah.
Equal to what? 16C. Is that also, sir?
Yeah.
Now we are asked to find the specific heat capacity.
Yeah.
To find this man, what do we do? Divide both sides by what? By 16, right?
Yeah.
And the specific heat capacity is now equal to what we have?
900. 900.
900, they have said joules per what? Per kilogram
Per second.
per Kelvin, right?
Kelvin, sorry.
Per Kelvin. That is all. Simple and
Straightforward.
straightforward.